Hello. Like Ben said, my name is Stefan Ubbink. I work for SIDN, the .nl registry, and I'm talking about the algorithm rollover for .nl. So a little bit overview of what I'm going to say is why did we do it, what did we do for the preparation, how did we plan it, how did we execute it, and what measurements did we do and what did we see in them. So why did we change the algorithm for .nl? We wanted to start using a saver algorithm, as in we used to use algorithm 8, and we wanted to go to algorithm 13, which was the new recommended version for which was recommended in the RFC last year. And there's enough support from resolvers to do this, as you can see in the graphs, pie charts on this page. And it also helps that our algorithm 13 gives smaller DNS-SEC answers, which makes us less vulnerable to reflection attacks, or at least we are less engaged in them, as in giving smaller answers. So for preparations, we got new HSMs, which were about to be replaced anyway, but the new HSMs are able to do about 20,000 signatures for algorithm 13 instead of the 200 the previous ones were able to do. And we ran a lot of tests. And during the tests, we ran a normal algorithm rollover on a test environment with a fake route, so we could validate the whole path. And also we used the local DNS-Viz to visualize that for ourselves. Afterwards, we also set up a fast policy to be able to see what happens during the rollover. And after that was tested a few times, we went to acceptance with real data. So we have in acceptance, we have a daily copy of the NL zone, and that we used for the acceptance environment. And we saw that the memory usage of the acceptance environment went very high, but no swap was used anyway. But adding swap made sure that the process continued. And there was also an issue that we needed more time for validating the zone, because ECDSA is a bit more intensive for resolvers. And we normally produce a new zone every half an hour. But during the transition, we were in the acceptance first time, we saw that we needed 45 minutes to generate and validate the zone. So that was not really fitting in our half an hour publication scheme. So we had to adjust some things and make some things parallel to run in parallel to be able to fit everything within half an hour. At RSA, we ran about 27 minutes to create a new zone, and on 25, sorry, and after the changes in acceptance, it was 27 for during the rollover, and after the rollover, it was to 22 minutes. So how did we plan everything? It was based on our acceptance run, and we had also external dependencies. For instance, IANA has to do some changes to be able to change the DS records in the root. And also, we wanted to make sure that we didn't do the algorithm rollover during a ZSK rollover, which is every 90 days in our situation. So we had to plan that. And this was the resulting plan. And the positive thing is that although there were some asterisks on the dates that are dependent on the external parties, we were able to manage to run everything according to plan. So it's quite similar to what VeriSign had in runtime or throughput time. We did prepare everything for production, so we could just copy and paste commands we needed to do. And before the rollover, our zone, .nl zone, was 4.5 gigabytes. During 6.4 gigabytes, and after 3.7. So there's quite some differences. We created public DNS viz pictures for everyone to follow the rollover. And we also prepared a blog post to mention to everyone that we were going to do this. So in case of issues, they would be able to know that we were doing this and not have to look at what was going wrong, and they were able to contact us. And there was a go, no-go situation, as in there was a point in time where we could go back without any issues, and we were looking at all the information we had to be able to say, yeah, it's okay, or no, we don't have any time more. So some of the pictures, they are in the presentation, so you can look at them if you want to. Measurements, we used a rollover mon created by my colleague Moritz Müller, and he did most of the measurements. We did quite some measurements, and you can see that in this picture there are a lot of key IDs, but those are not real key IDs, as in you see multiple lines at the bottom and at the top of the graph, and this is because of a measurement error. We looked at the data and we didn't consider the buffer size, so the packets were kept at 512 bytes, and the software was still trying to generate the key IDs from those packets. So that's why this was the result. We corrected that later on, and then we got better measurements. An interesting thing in response sizes is that for the NX domain and DNS key, it increased during the rollover, but for the NS record set, it decreased. And this was because the responses for the ns1.dns.nl got all glue, but before the rollover, it also includes the RR6 for most of the glue, but during the rollover, it only got the RR6 of the ns1.dns.nl in the additional section. So that's why the NS set response sizes decreased. If you look at the TCP traffic, sorry for the Dutch picture, but I didn't have any better. Before there was about 1% TCP queries, and during there were about 5% TCP queries. And after it went back to normal, as in 1% TCP queries. This is a view of the change in TCP traffic, and the y-axis is in logarithmic scale, so it's quite a big increase. Similar for UDP. This is NX domain. There are more NX domain queries, and 25% of the NX domain queries had 8 times more NX domain queries, and most were based on university measurements, but we didn't have any knowledge of errors that happened because of this. This is the graph of removing the RSA, and as you can see, now we only have 2 key tags, one for the new key and one of the RSA key. And in total, we didn't measure any impact on resolving, and I got confirmation from the people who run the resolvers at the largest ISP in the Netherlands, and they didn't get any questions about issues or anything, so that's a good sign. So this is our rollover, and I think it went good. Does anyone have any questions?
So being involved in some of this discussion, and we've seen now a couple of talks where resolvers sort of don't seem to be able to switch to TCP, and we see impact at the parent zone, but we never see any impact for end users. Does that mean we don't need to care?
A good question. What happens if someone doesn't get a reply? What does the user do?
Yeah, I mean, again, if there would have been some kind of impact for end users, I would guess that it would be picked up by the press, or you said you asked the resolve operators, they would have gotten calls. I mean, I know there are lots of tickets if people can't get a resolution. So that didn't happen.
No. I don't know if we really should care, or that we say it's good enough. Because how much do you need to do to accommodate everyone who doesn't follow RFCs?
Okay, thanks.
Tamás from PCH. You were saying that the zone generation took like 27 minutes and the validation. I would be interested how much was that the generation of the zone and how much was the validation. I would expect, and OpenDNS also like reuses like signatures. Yeah. So I would expect that this verification was long.
If you look at the general generation, etc., generation of the zone file itself is about 6 minutes. The signing is also about 6 minutes, and validation takes a lot of time, and there are also some other processes alongside which take some time, but that's roughly the time. If you want more information, come to me afterwards and can give you more details.
Okay, thanks.
Jeff Houston, I'd like to follow up on this issue of how do you measure the impact of a change on users resolving names? In other words, is there DNS resolver infrastructure capable of doing this resolution? And the answer we've heard both times is, well, no one hit the help desk, so it must have worked. And that's what you're saying. Now, I actually think there is a way of measuring this, and certainly this is what we do in APNIC, and it's a different kind of measurement. The way we do this is using a delegation that has no glue, none. So whatever's trying to resolve that name now has a second problem. I've got a name server name I need to resolve, and it's that name you stack the large answer, the truncated response, the problem. If they successfully resolve that intermediate name, they will go back to the original problem and give you the next DNS query. Because they've resolved the name server, they're able to ask it, and then the follow-up query will get made. The DNS can tell you if you're successful. And I would actually gently suggest to others contemplating this kind of move that if you're relying on the users to have close to a doctorate in DNS operations and be able to diagnose it to the point where they don't feel the help desk is going to diss them, then, you know, you really are, I think, operating on faith and trust. Whereas you can do, I think, a more structured measurement system where you actually get the DNS to try and resolve the problem and give you a consequent query if the resolver was able to unravel the problem. And I would gently suggest that others contemplating this might well look at that methodology very seriously. Thank you.
Thank you, Jeff. I think that answers a bit about the question Wes was asking to Dwayne. So
exactly. Yeah, thanks.
Thank you all.